Bismillahirrahmanirrahim. Call it preamble, call it pre-introduction, call it zero lecture, but this is just a small 15 to 20 minutes video piece regarding the course of algorithms. We would not discuss algorithms per se, but just the aim is that your apprehensions, because you would be new to this course, and the course which you will be studying next semester, it would be Introduction to Algorithms and Programming. Now that course is not just a major for computer science students, major requirement. It is also a requirement for about 20 other majors. And most of those students, they think that this course is unnecessary for them. For right or wrong reason, what I would not go into it. So this is just to make you familiarize, and just all the terminology, most of the terminology which we would be using in this course, I would try to discuss it through one example. The word algorithm may appear new to you, but you have been using it. You have been using it since your school days. You have been using it when you were walking, talking, and when you were making tea at your home, at your place, okay, you baking, cooking, and different games you are playing, the physical games, and all you have been using. So today I will not define the algorithms. I will not say anything about algorithm as far as the word algorithm is concerned, but I would just talk about one example from your school days, because all of you have gone to schools. Okay, and that example I would take to introduce you the main terms which would come in that. So let's go to what you say, the school example, how to add two numbers. When you first join the school, how would you add two numbers? Let's say 6 plus 3. You are little kids. There was an algorithm you would use in the beginning. What would you use? Fingers, of course. Most of you would use your fingers. And what you would do, you would count 6 fingers. After 6 fingers, you would count 3 fingers, and then you would write answer over here. This method was for small kids who can add small numbers, and the total is within their frame, within their space, and that space is the number of their, fingers. So let's say I am introducing space, or let's say memory. Memory are not your memory, memory means whatever is available to you. Okay. Then when you progressed, you change your strategy, and now you try what you would do. Somehow, that okay, I have not 10 fingers, but still I can, the teacher would tell you, still you can count more numbers. For example, if it was, like, say, to add 9 plus 4, obviously, the sum is more than your fingers, but what you would do? You would start counting after 9, so then you would say, so this is one algorithm to add 2 digits. Now I am giving you a modification of that again you are using fingers, but now you would start with after one number, and usually it would be the largest one among the two. And then you would count after it 4 fingers. So these are 4 fingers, so you would say 9, 10, 11, 12, 13, and you would write the answer. Okay? But then what you can say, that the numbers are a lot bigger than that. Then what you did, you modified in the space of time, you modified your algorithm, and what you would do, you would draw lines. For example, here you draw 9 lines. You see 9 lines, and then you draw 4 lines. And then you would count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13, and you would write the answer. Now, this algorithm is good. It would always give you a good result. we call it, I'm using the word algorithm, this was your method, but that isn't an algorithm. You were using it. Now, let's come back to, again you modified if when you wanted to save time, what you did, you would draw 4 lines and count after line. Good. And this algorithm is good, perfect. So what is the problem with this algorithm? Yeah, of course, you cannot add bigger numbers. You can add bigger numbers, but maybe it is not efficient. For example, 817 plus 9321 5. Can you add these two numbers by this method? Anybody? Yes? Of course, you can add. All you have to do, you draw these many lines and count it. The problem is against twofold. Number one, is your space, maybe your page, your whiteboard, okay, is it enough to draw that many lines? And then you count it, okay? So again, the problem is space. By the way, we call memory in your computer, the random access memory, RAM, is also called whiteboard memory in this way. So the analogy is there. Now twofold I said the problem. One, yes, of course, space. And the second, time. How much time, how much speed you would take. Okay. So now yes, this is a correct algorithm, but the problem is this is not efficient in two respects. One, you cannot use that method efficiently in two senses. One, space. You would require a lot of space to draw that many lines. And secondly, you would require a lot of time to count those. So then what you did in the next class, in the in the subsequent classes, you modified the algorithm for these. And you didn't modify, you were still using this algorithm, but you introduced another super algorithm on it. Okay? So still you were using the same to add the digits. Yes, you retained it. So that is why I will now introduce another term, reuse. You didn't discard this method. But now, for bigger numbers, you introduce another algorithm that would use this algorithm. Now here, when we add these things, you know, I'm quick on these because we don't have time. So what we would do, we would add the two numbers, two digits. But the problem is, should we start from here or here? So where would you start? Obviously from this side. So it means order is important. You are not starting from here or here, you are starting from here and you are going in this direction. You are going in sequence. I am using the word sequence. So in sequence, from right to left, you would add these digits one by one, based on their position. Then I would also write an Arabic name for it. Let's say if you are because most of my students would be Arabic. So 30. You are following a 30. Okay. Now look at it. How would you do that? You would add, and what you would get? A number. But now you would not write the number directly. You would check. If your number is more than 9, means if your number is greater than or equal to 10, you would write the unit digits. For example, incidentally, this number has more than, the sum is more, these two digits, sum is more than 10, so you would write the unit digit and you would write the Baki, what you call, Hasil Baki, what you call it, the 10th digit over here. Now I am coming to two new concepts. Number one, you added and then you decided based on the sum. You said, if my sum is greater than 9, then I would take the unit digit and I would write the unit digit over here and I would write I would memorize, I would say, the 10th digit and add for the subsequent digit addition. So with this thing, where I have to choose between greater than 9 or not greater than 9, this gives me another concept, selection. I am selecting. Yes, I am following a sequence, but I am selecting. In Arabic, I would call it ikhtiyar. Good. Now let's come to the next one. Subsequent digit 1 plus 1, 2. 2 is less than 9, so but 2, and this one which you memorized, which you wrote here, you would add these 3. If that is greater than 9, you would write the unit, and so it is not, so you would write just the digit, and you don't need anything. Now here, this thing, why would you do that at that time? Why you write it? Because this was, you needed to memorize that so that you don't forget it. Memorize. Okay, so you would store it at a fixed place over there. So from this we come with another concept, which is to store. And to store in what? In a variable. This we would call variable. By the way, the concept of variable is from this storage where you are memorizing. That means that you would need a place, but you need to, variable would come later on, but you would store it in a place where you would name it. That is why it is called a variable. Okay? So you would see, we would call variable, it is different from mathematics. In mathematics, variable is something different. We call it mutaghayyir, but it is different. Here, by variable we means the named place. And who name it? You, the programmer, the algorithm writer. You yourself would give its name so that you don't forget. And when you put something in it, we call it, you store it. Or we use store, but we use the word assign or assignment. Okay? So now, so far these terms I have used, and these would be mostly your terms in this whole course. Now, look at it, one more thing. Now, again, you would add these two and you would get something. If it is greater, you would come here and you would add. Now look at it. You are doing it every digit the same, and let's let's standardize it. This is 0, because nothing in there. Okay? So for this, let's say I have a placeholder where I store this and I add it every time. In the beginning it is 0. Here. So I add this plus this plus this, which is this. Okay? So this, whatever I get, let's say 3, the other digit would override for this addition. So then this plus this is 3. Then again, because the 10th digit is 0, so I will put here 0. And then this plus this is 10, so this would be 1, and so on. Now look at this place. Let's call this place Baqi, or let's say any variable. This place where I am storing the third value which I add to it, I call it a variable. And because I would need many such things, I would name it. Here I have named it Baqi, I will call it X. And this is the variable, or placeholder. Variable is a placeholder for something which you don't want to forget. So it is there. So now standardize. Every time you would add these, okay, and you would get something which you which you would write over here. Now the last one you would write the whole. Now look at it. Every time we are doing the same thing. What we call it in normal? If you are doing again and again the same thing, obviously repetition. So another thing is repetition, which we call, in Arabic I would use the word takrar. And this repetition is not unlimited. This is not la mahdud in Arabic. Because we would stop somewhere when both these digits are 0. Okay, we would add it to the last one and we would stop. So there is a stopping criterion for this. Okay, we would define later on, but I'm not giving that name intentionally. We would just restrict to these. So now, from all this example, what we have got? We started from a simple algorithm. We said that algorithm is not enough because the space of that algorithm or the memory required for it, it's limited, and the speed is not good. So what we did, we modified the algorithm. We introduced another algorithm, but we reused the one we developed for adding the digits. And then what we did, during the course of this addition, we came across three important concepts or structures we could call. Sequence, yes, we started from a tartib. Selection, yes, we had ikhtiyar, we had to select between two ways. We would do one of these two things. One, if it is more than 9, we would take the unit digit, but we would store the, the 10th digit. Otherwise, we would just write the unit digit. So in both cases, we would write the unit digit, but we would store. To standardize it, we would say, okay, every time we would store the 10th digit and we would write the unit digit. 10th digit, if it is 0, we would store 0. If it is 1, you would store 1. To start with, so we did it. So we have say sequence, we had selection, and then we are the same thing we are repeating. This is repetition, these three things. Okay? And now, here when we started, at the start when we were adding, from our side we put something in it which was 0. We said we initialized this variable with 0. So I am also writing the word initialization. It is a very heavy word, but it simply means the beginning value which you store in your variable from the beginning, from your side. Okay? So now we have these concepts. We have the concepts of variable initialization, and variable assignment. Whatever the act of storing is assignment or assign. Then we have the concept of reuse. We have time and space in the framework, okay, where we would do the efficiency, and then we have these three constructs, or three control structures: sequence, selection, and repetition. And this course will be all about these things. Okay? Remember, algorithms are programming. Programming is a way to express algorithm. They are all, this is programming, I would say, it is expressing your algorithm. It is like driving. The driving lessons are very few, but you need practice, okay, in driving. So the more you have practice, the more better you are a programmer, and the better you are a driver. So these, we will all revolve around these. The one thing which I need from you, don't be absent. I would say by absence I mean physically and mentally you must be, and practice. You must be present and practice. So I would also ensure that I will, each class I will exercises that you do, and those would be graded accordingly. So these are the main terms which you would come across. Again, I repeat, there is space and time. You know, from physics, always these are two important things. Space would be memory, time would be speed. Both need efficiency in both. Yes, you start with simple things and we would reuse it in a bit complex things and a lot complex things. Then we have sometimes we would memorize things, and for that there is a concept of variable. To store something in a variable, we call it assign. Sometimes, and many times, you would initialize a variable, you put from all sides, and then these three. I would end this thing with a very famous theorem, which is called structured, don't be afraid of these, okay, programming theorem, which says any algorithm can be expressed, okay, By using these three things, it is mathematically proven. There is a theorem, so you can write algorithm for any. And why we need algorithms? We want to solve our problems. It is mainly problem solving. What problem you face, we usually use it for problem solving. The word is the problem solving, the phrases. And for this we all need these things. So this is all about what we say, the algorithms, and these are the main, this was just that algorithm is nothing to be fearing about. All we need is these concepts, understand these concepts. And it will be easy for you, but you need to keep track of these things. Okay? Thank you very much, and I hope I have allayed your apprehensions about this course. You are all welcome to join the course. Again, I would say, be physically present, be mentally present in the classes to come, and practice. Practice. And this is the key course, especially for computer science students. This is a very key course. If you are good in this course, you would be for 4 years you will enjoy. If you are bad in this course, forget about it. You would be a problem for us and yourself also. So better, you need to concentrate on this course, both physically, both mentally, and you need to practice. Thank you very much.